Here we are dealing with elimination constant, and it's very rare, that you will have such type of questions. But anyway, I would like to show you how we can calculate half-life. The half-life can be calculated as 0.7 volume of distribution over clearance, or half-life can be calculated as a 0.7 divided on constant of elimination. And if you have constant of elimination 0.35, half-life can be calculated as a 0.7 divided on 0.35, and it will be 2 hours. Question is asking how long it will take to reach steady state after the infusion begins. To reach steady state concentration, we need 4 or 5 half-lives, and this will correspond to either 8 hours or 10 hours. So in this period, what answers we have? 9 hours. This will correspond to the 9 hours. Next one, time to reach steady state concentration. Yeah, how long it will take. Volume of distribution 5 liters, clearance 0.05. First order kinetic. How long it will take to reach steady state concentration. Once again, time to reach steady state concentration, 4 or 5 half-lives. We should find a half-life here. And this will be 0.7, volume of distribution 5 liters over 0.05 liters per hour. Liters, hours. Can calculate will be 10, 100 multiplied on 10 will be 70 hours, right? And 70 hours, if we will multiply on 4, we'll have 280 hours, on 5, 350 hours. So between 480 and 350, 280 hours. That will be a time to reach a steady state concentration. So we have K0, IV, bioavailability is 1. Begin 4 hours. Time interval 4 hours. Earlier at the rate 10 milligrams per minute. So K0, 10 milligrams per minute. Drug X is a volume of distribution 100 liters. And the clearance 0.5 liters per minute. If the rate of infusion remains constant, what will be plasma concentration at steady state? So actually, question is asking us about steady state concentration. Steady state concentration can be calculated as a K0 over clearance, or maintenance dose tau clearance. Do we have clearance? Yes. Do we have K0? Yes. Let's go. So it will be 10 milligrams per minute over 0.5 liters per minute, and it will be 20 milligrams per liter. During investigational study, new antifungal medication shows half-life 6 hours. How long it takes to reach 75% of steady state concentration? 2 half-lives, 2 by 6 will be 12 hours. 100 milligram of drug A, given orally, so you should think about bioavailability every 6 hours. So tau is 6 hours, 70 kg. Bioavailable fraction after oral dosing. So bioavailability is 50%, do not miss it, or 0.5. The drug is eliminated by first order elimination. Half-life 6 hours. Fractional volume of distribution 0.7 liters per kg. A lot of information. How long it will take approximately to reach plasma concentration? 95% of steady state concentration. So 95% of steady state concentration time. We know that this time equal to 4 or 5 half-lives. So we have half-life 6 hours. So 6 on 4 will be 24 hours, and 5 on 6 will be 30 hours. That's it. 4 on 6 will be 24, and 5 half-lives will be 30 hours. This is the time to reach steady state concentration.